Hello viewers, in this video we will discuss the problems related to thermodynamics topic which is related to NEET exam. Okay, and for your information I have also added a Google form which is displayed in the description box which consists of 15 questions which is used for you for the purpose of practice. Okay, so we will go to the problems. So in the first problem, see that. So here they given if the delta U and delta W represents the increase in internal energy and work done. So delta U represents the increase in internal energy and delta W represents the work done by the system respectively in a thermodynamical process. Which of the following is true? Okay, so see the options. So here we have delta U is equal to minus delta W in an adiabatic process and it is equal to delta W in an isothermal process. Delta W, it is delta U is equal to delta W in an adiabatic process and minus in an isothermal process. Okay, so now what is the equation for the first law of thermodynamics? So you will be using this equation to find the answer for this problem. Okay, so first option C, we have an adiabatic process. So you know that in case of adiabatic process, the heat quantity is nothing but it is 0. So there is no heat addition, no heat rejection in case of a adiabatic process. So from this we can say delta U will be equal to minus of delta W. So change in internal energy is equal to minus of change in work done. Okay, so from these options we see that the first option is the right answer. So remaining things are not correct. Okay, because in case of isothermal process, you see that from the first law of thermodynamics, in case of isothermal process, there is no change in internal energy. So you see that delta U will be equal to 0 in case of your isothermal process. So these options will be not correct in case of your isothermal process. So option A is the right answer for this problem. Okay. So the second problem, so which is asked in NEET 2012. So see the question. A thermodynamic system is taken through the cycle ABCD. So we have a cyclic process here, as shown in the figure. Now heat rejected by the gas during the cycle is, we have to find the value of the heat. Okay, so here they are given the PV diagram. Okay, so pressure volume diagram is given. So we have to find the heat rejected. Okay, so from first law of thermodynamics, you know that delta Q is equal to delta U plus delta W. So we have to find the delta Q value. Okay. So as it is a cyclic process, see that as it is a cyclic process, in case of a cyclic process, the change in internal energy is equal to 0 because the initial and the final value are both equal. So this value becomes 0. So the delta Q value will be equal to delta W. So we have to find the value of delta W from this PV diagram, which is equal to the heat. Okay. So in case of a cyclic process, okay, in this PV diagram, the area enclosed by the closed curve is the work done. Okay, so the area enclosed by the closed curve because it is a cyclic process. Okay, so here the area enclosed by this curve is a rectangle. So what is the area of the rectangle? So the delta W value is nothing but the area of a rectangle, of this rectangle ABCD. So just given as, see, the value of L is 2V. And the value of their breadth is, it is P. So delta W is given by 2 PV. So which is equal to delta Q. So delta Q is equal to 2 PV. Okay, so that is the option B is the right answer. Okay. The third problem. Okay, so it has been asked 2011 NEET. Okay, see in the third problem, they given the question as during an isothermal expansion, a confined ideal gas does minus 150 joules of work. So work done is minus 150 joules is given against the surroundings. This implies that, so they are given 4 options. Okay, so for the first option, 300 joules of heat has been added to the gas. Then no heat is transferred because the process isothermal. 150 joules of heat has been added to the gas and 150 joules of heat has been removed from the gas. Okay, so from the first law equation, you know that delta Q is equal to delta U plus delta W. So as it is an isothermal expansion, you know that delta U becomes 0. It is 0. So delta Q automatically it is equal to delta W. So what is the work done here? Minus 150 joules. So automatically delta Q becomes, it is equal to minus 150 joules. Okay, so what this denotes? Okay, so it says that minus 150 means the heat is either rejected or you can say that heat is removed. Okay, so if the value of heat is minus, it means that heat is rejected or heat is removed. If the value is plus, it means that heat is added or heat is observed. Okay, so in case of work done also, work done on the system, let us take it as negative. Work done by the system, let us take it as positive. Okay, so here the value is minus 1, it means that heat has been removed from the gas. Option D is the right answer. So next and fourth and fifth problem in general. Okay, in general they are given. So in an isochoric process. Okay, so here we see that we have an isochoric process. So if T1 and T2, so isochoric process, it means that it is constant volume. It means that it is constant volume. So T1 27 degrees Celsius and T2 is equal to 127 degrees Celsius. Then the ratio of pressures, they are asking the pressure ratio P1 by P2 value. What is the ratio? So in case of constant volume process, see that from ideal gas equation PV is equal to mu RT, when volume becomes constant, here we can see that pressure is directly proportional to temperature. Okay, so from this we can write this value P1 by P2 will be equal to T1 by T2. Okay, so T1 is given as 27 degrees Celsius, convert it to Kelvin. So what is the value? So that is plus 273, which is equal to 300 Kelvin for this one. And here this is 127 plus 273, which is equal to 400 Kelvin. Okay, so here P1 by P2 will be equal to 300 by 400, which is equal to 3 by 4. So the ratio P1 by P2 is equal to 3 by 4. So this is the answer for this fourth question. So now fifth question. Here they have given that if 0.3 liters, this is 0.3 liters of a gas at 27 degrees Celsius is cooled to 7 degrees Celsius at constant pressure. Okay, so in case of constant pressure, you see that, so when this pressure becomes constant, we can say that volume is directly proportional to temperature. Okay, so here they're asking final volume. Okay, so we can replace this equation like this. So V2 by V1. So V2 by V1 will be equal to T2 by T1. Okay, we have to find the value of final volume. Okay, so from this V2 could be written as V1 into T2 by T1. So what is the value of V1 given here? It is given as 0.3 liters. So what is T2 and T1? So here it is at 27. T2 it is given as 7 degrees Celsius. So 7 plus 273, which is equal to 280. Then 27 plus 273, which is equal to 300. Okay, so it is 280 by 300. So from this, so when you divide it by 0.3 by 300, you will be getting the value as 280 by 1000, which is equal to 0.28 liters. So the value of V2 is 0.28 liters. So option C is the right answer for the fifth question. Okay. So now the sixth and the seventh question, okay, in general, okay. So here they given which of the following is not a state function of the system. So here they given four options: temperature, pressure, specific volume and heat. Okay, so state function, it means that it does not depend on the path taken. Okay, so it could be defined on a particular state. So from this we can see that temperature, it is a state function, it could be specified on a particular state, and pressure, it is also a state function, it could be specified at a particular state, and specific volume also, it is a state function, it does not depend on the path taken. Okay, so heat is not a state function, it is a path function, only the path determines the value of the heat. So from these four options we see that option D is not a state function. Okay, so next question, seventh one, the work done during an isothermal processes. So in case of isothermal process, we have to find out what is the value of the work done. Okay, so now, so the work done for isothermal process is given by the integral of P dV. So the limit is, we have V1 to V2. Okay, so you know that from ideal gas equation, PV is equal to mu RT. So from this P could be written as mu RT by V. So I'm going to replace this P value by these equations. Okay, so integral of V1 to V2. So mu RT, so this is dV by V. Okay, so this could be written as mu RT, so integral of dV by V, V1 to V2, which could be written as mu RT log E of V, that is V1 to V2. Okay, so this could be replaced as, so you know that PV is equal to mu RT. Now the PV is equal to mu RT, so it could be written as PV log to the base E. So when you apply the limits, it becomes V2 by V1. So in general, we're getting PV log of V2 by V1. But in options, we're having P1 V1 or P1 V2 like that. So you know that isothermal process, you know the temperature is constant. So it could be, the equation could be written as P1 V1 is equal to P2 V2 is equal to constant, because PV is equal to constant. So P1 V1 or P2 V2. So here we can write either P1 V1 or P2 V2. So see the options. So here we have P1 V1 log of V2 by V1, okay, which is correct. Let us see other options. So P1 V2 of log of V1 by V2. So this could not be correct. See here it is P2 V2, but it is represented as P2 by P1. Okay, see, in case of PV, the volume and pressure are inversely proportional. So if it is V2 by V1, it should be written as P1 by P2. If it is P1 by P2, it is right option. Okay, so it could not be the right answer. This is work done by adiabatic process, so it could not be the option. So this is the only option, P1 V1. This is P1 V1 log A of V2 by V1. So option A is the right answer. This is the work done of an isothermal process among the options given. Okay. Okay, the eighth problem. So see, in this problem, they given a mass of diatomic gas. The value of gamma is 1.4 at a pressure of 2 atmospheric. Is compressed adiabatically. See, it is compressed adiabatically so that its temperature rises from 27 to 927 degrees Celsius. The pressure of the gas in final state is. So here they given the temperature values and they are asking the final stage pressure value. Okay. So in case of adiabatic process, we know that the equation PV power gamma is equal to constant. So the pressure volume relationship is given in case of adiabatic process like this. From ideal gas equation, you know that PV is equal to mu RT. So instead of this volume, I am going to replace it by T by P. Instead of V, I am going to replace it by T by P. So this equation could be written as P. For V, I am going to replace by T by P gamma, which is equal to constant. Okay. So P into T power gamma by P power gamma, which is equal to constant. Now I am going to bring this P down to the denominator. So P power gamma by P power gamma by P, which is equal to constant. Okay, so now T power gamma by, so take this P to the numerator, so it could be written as P power gamma minus 1, which is equal to constant. So now divide by gamma on the numerator and denominator. So it could be written as T by P power gamma minus 1 by gamma, which is equal to constant. Okay, so this could be written as T1 by P1 gamma minus 1 by gamma, which is equal to T2 by P2 gamma minus 1 by gamma. Okay, so now replace the equations. So it could be written as, so T2 by T1 could be written as P2 by P1 whole power gamma minus 1 by gamma. Okay, so but we need the value of pressure. Okay, so yeah, I'm going to replace this equation. So this equation could be replaced by, I'm going to take this values of gamma to the temperature side. Okay, so now it could be written as, see that P2 by P1, here it is equal to T2 by T1. So this value will be in reverse. Okay, it will be written as gamma by gamma minus 1. So when it comes here, it will be reversed. Okay, so gamma by gamma minus 1. Okay, so now P2 will be equal to, so P2 will be equal to P1 into T2 by T1 whole power gamma by gamma minus 1. Okay. So now substitute the values. So P2 will be equal to, what is the value of P1? It is given as 2. Okay, so what is the value of T2? So here it is given as 927 degrees Celsius. So 927 degrees Celsius means 927 plus 273, which is equal to 1200 Kelvin. Okay, so here it is 27. It means that 27 plus 273, which is equal to 300 Kelvin. So 1200 by 300 whole power. The value of gamma is given as 1.4. So 1.4 by 1.4 minus 1. So which could be written as 2 into, this ratio is 4. So when you cancel it, this becomes 4. This ratio 1.4 by 0.4. So this ratio 1.4 by 0.4 is 3.5. Now see, sorry, this is 4. Now see, this 4 could be replaced as 2 square 3.4. So which in turn is equal to 2 into, so now multiply this 2 into 3.5, it becomes 2 into 2 power 7. Okay, so this 2 power 7, when you multiply, it will be, the value is 128. So 2 into 128, which is equal to 256 atmosphere. So the value of P2 is 256 atmosphere. Okay, so option C is the right answer for this problem. Okay. So the ninth problem, see, in this problem they are given, which of the following is correct in terms of increasing work done for the same initial and final state. Okay, for the same initial and final state. So you know that from the first law of thermodynamics, delta Q is equal to delta U plus delta W. Okay, so for the same initial and final state, you know that the change in internal energy will be equal for all the process. So now we have to see the work done. So the work done will be represented always in your PV diagram. So now we will draw the PV diagram for all these three processes for the same initial and final states. For the same initial and final states. So let us take, this is 1 and 2. Okay. So first let us take, we have three processes in this among the equations. We have isobaric, isothermal, adiabatic. Isobaric means it is constant pressure process. So the constant pressure, it is taken from one state to another state. So you see that. So this is the pathway taken for your isobaric process. Next we have isothermal process. So the isothermal process, the curve will be a little bit steep when compared to this isobaric process. So this is the pathway followed by the isothermal process. Okay. Now adiabatic process. The adiabatic process, the slope of adiabatic process is always greater than the isothermal process. So the curve will be a little bit steeper when compared to this isothermal process. Know that the slope of adiabatic process is always greater than the isothermal process. See, this is isothermal and this is adiabatic. So the slope will be, this is the slope of adiabatic. So it is always greater than the isothermal process. So I have represented the curve, the path followed by all the three processes. Now what is the work done? So work done is the area enclosed by the curve. So see, in case of this, the area enclosed by the isobaric process, see, in case of isobaric process, this is the area enclosed by the curve. Okay, 1 and 2 for isobaric. Okay, now when compared to next is we have isothermal. Isothermal, here see that this is the starting and ending point. So this is the curve for isothermal. Okay, next we have adiabatic process. So in adiabatic process we see that more steeper. So it is adiabatic. So compare the three images. From this we see that isobaric, the work done is more. Next one will be, next reduced value is isothermal and next reduced value is adiabatic. Okay, so it will be in the descending order. So see the options. So here we have adiabatic, isothermal, isobaric. So isobaric is more, then we have isothermal, then we have adiabatic. Okay, so here they have represented their descending order. So option A is the right answer. Okay, because isobaric is more, next level is isothermal, next is adiabatic. Okay, so when you compare these three equations, option A is the right answer. Now the 10th problem. So here we see that 1 mole of an ideal gas goes from initial state A to a final state B. We have two processes. It first undergoes isothermal expansion. So first it undergoes isothermal expansion from V to 3V, that is the A moves from this point to this point. Let us take it as point O. Which is not given in the question, just we are assuming. Okay, and then its volume is reduced from 3V to V at constant pressure process. Okay, so this is the condition given and we have to find which PV correctly relates this representation. Okay, so see that from option A we see that, so A to O, it is correctly represented as an isothermal process from A to O, and O to B also It is compressed. It is moved from 3V to V at constant pressure process by a constant pressure process. So A is okay. Now let us see the remaining diagrams also. So here it is also isothermal and constant pressure, but the arrow mark is in opposite direction. See, from B to O it is represented from, it is moving from V to 3V. So it is not correct. Okay. Next we see this C here, AB and BC. OB it is not under constant pressure process. Okay, so it is also not correct. Okay, so here OB is correct, but we see that from A to O it is not isothermal process. So they have given a straight line. So you know the isothermal curve is a curved line. Here they are given a straight line. So this is also not the right answer. So option A is the right answer. Okay. So here in this 11th problem, see that an ideal gas goes from state A to state B. We have three different processes. See, it moves from A to B by three pathway. See, one is this is the first pathway, this is second one, and this is the third one. So the initial and the final point are same, but the pathways are different for these processes. So if Q1, Q2, Q3 indicate the heat observed, these are heat observed by the gas along the three processes, and delta U1, delta U2, delta U3 indicate the change in internal energy along the three processes respectively. Then what are the options? So here options are given with respect to heat and internal energy. So see that here the starting and the final point are the same for the three processes. So automatically it says that the internal and change in internal energy will be equal for all the three processes. Okay, so among these two, maybe these two equations. Okay, these two options. So these two options will not be the right. Okay, next one. Now here you see this, as the change in internal energy equal, the heat will be automatically equal to the work done. The change in heat will automatically be equal to the change in the work done. Okay, so now what is the value of work done here? So the area enclosed by these curves. So the first one, see, the first one, it will be like this. So this will be the curve like this. Okay. So this is the area enclosed. Now second one you see that this is the area enclosed. Now the third one you see that this is the area enclosed. So from the diagrams you see that 1 the work done is more, 2 it is less than 1, and 3 it is less than 2. Okay, so from that it means that so work done of 1 is more, 1 is more, then 2, then 3. So from this we can say that Q1 is more, then Q2, then Q3. Okay, so option A is the right answer, because here the internal energies are same and the order of the heat observed will be 1, 2 and 3 with respect to the given diagram. Okay, thank you. Okay, now the 12th problem, a general problem. Here we see that a system is taken from state L to a state M. So it is taken from state L to state M through the pathway LQM. So for this pathway LQM, they have given some information. The heat supplied is Q is equal to 168 joules and work done is given as 64 joules. Okay, so along the path L and M, see that here L and M, the heat is given as Q is given as 125 joules. So if the full stop. Okay, now if W is equal to minus 42 joules for the curved return path, that is, it has reached from L to M through this path LQM and L and M. But the return path here they have given as M and L, M to L. So in this return path, they have given the value of W as minus 42 joules. Here we have to find the Q for this return path. Okay, so first let us take the pathway LQM. So let us take the path LQM. So Q in case of LQM will be equal to delta U in terms of LQM, then plus work done delta Q delta W in terms of LQM. Okay, so now from this you know the known values are delta Q and delta W. Okay, so what is delta U now? So delta U of LQM will be equal to, here the value is given as 168 and 64, that is equal to 168 minus 64, which is equal to 104 joules. Okay, so here see this delta U is nothing but change of internal energy. So what is the final value? UM minus UL, because the initial point is L and the final point is M. So UM minus UL value is 104 joules. Okay, so in this path ML, so let us take the value will be in reverse order, because In this path ML, the initial point will be L and the final point will be L. So this could be written as UL minus UM could be written as minus 104 joules. So the change in internal energy through this path is minus 104 joules. Now we can find the value of Q. So Q will be equal to delta Q will be equal to delta U plus delta W. So here we have delta Q is equal to, so you know delta U is minus 104. Here W is given as minus 42, so minus 42 which is equal to minus 146 joules. So delta Q among the path ML. Okay, so this is delta Q among the path is ML. This is equal to minus 156 joules. So option C is the right answer. So here 13th problem, a general problem. See here they given that calculate the work done by the gas in the state diagram shown. See, this is the diagram given. Okay, so now we have to find the work done. Okay, so let us consider it as a closed path. So the work done here it could be written as the area of this triangle. The area of this triangle will give you the work done. So here it is half into, now what is the B value? It is 250. So here it is given as cc. Cc means it is cubic centimeter. We have to convert it into meter cube. So I am multiplying it by 10 power minus 6. So it is converted into meter cube. So here the value of pressure is also given in kilopascal. We have to convert it into pascal. So for kilo 10 power 3. So the value is 120, 200, it is 80. Difference is 80. 80 into 10 power 3. Okay, so from this 2 and 4, so 40, 250, 10 power minus 6, so 10 power, so 250 into 10 power minus 6 into 40 into 10 power 3, so 250 into 40 into 10 power minus 3, so when you do the calculation you will be getting it as 10 joules. Okay, so whether it is plus or minus. Okay, so now whether we have to think whether it's plus or minus. So here we see that for this to represent whether it is minus or plus, we have to see the arrow mark direction. See here, this arrow mark direction is in the anti-clockwise direction. So this anti-clockwise direction represents that the work, it is a work consuming process or work is done on the system. Okay, so the value will be minus. Okay, so if it is a clockwise means you see that work producing or work is done by the system. Okay, so here it is minus, so option D is the right answer. So okay, in this 14th problem, see that the figure below shows two paths that may be taken by a gas to go from a state A to state C. So A, B, C and AC. So in process AB, so they given specifically for different process the heat supplied. AB, the heat supply is 400 joules of heat is added, so 400 to a system. The heat absorbed by the system in the process AC will be, oh, something is missing, the process BC. So right in the 14th problem here we see that figure below shows two paths that may be taken by a gas to go from state A to C, the ABC and AC. So in process AB they given 400 joules of heat is added to a system, and at BC 100 joules of heat is added to a system. We have to find the heat absorbed by system, the process AC. Okay, so here you see it sees that it is a cyclic process. A cyclic process. So in case of cyclic process, see that the net heat among A, B, C will be equal to the net work done, W in A, B, C. Okay, so net heat supplied will be equal to the net work done in a cyclic process. Okay, in the first law of thermodynamics. So what is the net heat supplied? That is equal to QAB plus QBC plus QCA, which is equal to net work done. So it could be found from this graph, on this diagram. So see, we have area of this triangle. So we have half into, so here we have 2 into 10 power minus 3 into this value 2 into 10 power, sorry, 4 into 10 power 4. The difference is 4 into 10 power 4 Pascal. Okay. So here we see 2 gets cancelled. Here it will be 40. So here you know that the value of AB, this is equal to 400 and this is 100 plus Q CARAC. This is equal to, here it is 40. Okay, so from this QAC will be equal to 500 minus 40, that will be equal to 460 joules. So QAC is equal to 460 joules. Okay, so it is AC. So option C will be the right answer. So, right, in case of this 15th problem asked in 2017, see, ideal monoatomic gas is heated at constant pressure. The fraction of the heat energy supplied which increases the internal energy of the gases. So, we have to find the fraction of the heat energy. Okay, so here the fraction is nothing but the internal energy by heat. So, here what is the change of internal energy with respect to the heat? We have to find this fraction. Okay, so you know that Q delta R, Q will be equal to mu Cp delta T. Okay, so because the heat is applied at constant pressure. Okay, so mu Cp delta T, Cp is nothing but the molar specific capacity at constant pressure. So mu is nothing but the number of moles and change in temperature. Delta T is a change in temperature. So now what is for delta U, which is equal to mu Cv delta T, because it is the heat content at constant volume. Okay, so now as it is a monoatomic gas, in case of a monoatomic gas, the value of Cv is 3 by 2 into R. R is a universal gas constant, and the Cp value is 5 by 2 into R. Now substitute these values in this equation. So you know that this is mu Cv delta T divided by mu Cp delta T. Okay, so mu, the value of Cv is 3 by 2 R delta T by mu 5 by 2 R delta T. So mu R gets cancelled, 2 gets cancelled. So final answer will be 3 by 5. So 3 by 5 is the right answer for this problem. So next problem we have, a thermally insulated rigid container contains an ideal gas heated by a filament of resistance 100 ohms through a current of 1 amps for 5 minutes. Then change in internal energy is. See that here they given a thermally insulated. It means that outside heat cannot go inside a container. See, the container is a rigid container. So rigid container means that there is no change of shape, there is no change of volume for whatever may be the condition in case of a rigid container. But heat is being supplied. See, electrical energy is being converted into heat energy in this particular process. So heat is being given by a filament of resistance 100 ohms through a current of 1 amps for 5 minutes. So what is the value of heat? So value of heat with respect to this electrical energy is given by I square RT. So I represents the current, R represents the resistance, and T represents the time in seconds. So here you know I square is the value of current is 1 amps. So R is they are given as 100 ohms and time they are given as 5 minutes, convert into seconds. Okay. So here this will be, so which is equal to 30 kilojoules. So Q is 30 kilojoules. Okay, they are asking the value of change in internal energy. So here as the container is a rigid container, so there will be no change of volume. So the work done value will be equal to 0 for this process. So which in turn it says that change in internal energy is also equal to 30 kilojoules. So option D is the right answer for this problem. Okay, so these are the problems in part 1. Okay, so try to attend this Google form which has been displayed in the description box, which will be useful for you to practice. Okay, thank you.